All right, so on number 20, we're asked to figure out the values for a and b that would make this piecewise function continuous. All right, so let's take a look at what's happening on the graph, and then we'll do the algebraic analysis to figure out the values of a and b. All right, so let me do a rough sketch of what's actually happening and what we're doing graphically, and then we'll kind of apply some algebra to it. So here's like a rough sketch of what's happening here. All right, so with piecewise functions, we've got these decision points where the function changes rules. Okay, so we notice here the function is going to change at 0 and at 1. Okay, so something different is going to be happening in 3 different sections. All right, so if we take a look at the first section, anything below 0 is just a constant function of pi. All right, so it's the function, I'll do it in red. Actually, I'll do each piece in a different color just so we know what's going to happen. So this is what the function would look like. It's a constant function at the value of pi, and then at between 0 and 1, something different happens. So between 0, we'll call this 1. Again, it's just a rough sketch. And we know, let's go with purple. We love purple. We know that it's going to be some type of quadratic, right? So if the function is continuous, then it has to meet up at pi, right? So the function would have to meet up with this line over here, and it's going to look something like this. But in order for it to be continuous, at 0, it has to be the same height as the first piece, right? So in order for the purple line and the red line to match up, right at 0, they have to be the same value. Okay, that's kind of the idea. And then in the third one, let's go with, I don't know, green. This is a linear function for anything beyond 1. Right? So it's got a positive slope, so just a rough sketch would look something like this. And in order for this to be continuous, this has to meet up at the same height with the purple function. So we want whatever's happening at 1 to kind of collide and make sure it's the same height. Okay, so what we're doing algebraically is finding the values where these two functions meet up at the same value, which in this case is pi, and where these two functions meet up at the same value, which we don't know yet. Okay, all right, so that's essentially what's happening. All right, we want to make sure that at the decision points, each function attains the same height. Okay, that's the idea. All right, so let's do that algebraically, figure out what the values are going to be. So the first thing I'm going to do is I'm going to take the first two functions and I'm going to set them equal. Okay, so we have the first function is just pi is going to equal the second function. Now when I do this, algebraically what I'm saying is that the y values are going to be the same. Okay, the y values here are the same. That is going to ensure that they meet up. All right, so we're just setting the y values or setting the function equal to each other so that they match up. And then I'm going to plug in where I need them to match up. Okay, so the first decision point is at 0. So when x is 0, I need the function to match up. So wherever I see an x, I'm just going to plug in 0. Okay, that's the location of the meeting. All right, so setting it equal is ensuring that they're the same. Plugging it in 0 is going to ensure where that's going to happen. Okay, so we'll just have 0 squared plus a times 0 plus b. All right, which of course is going to be pi equals, this will cancel, and then we're left with b. Okay, so what that means is when the b value is pi, then the functions are going to match up, okay, which makes sense because in a quadratic, this is your y-intercept, right, that last constant, and it has to be the same as the other function, which is happening at pi, which means it's going to hit the y-axis at pi. So it makes sense that b would be pi, right? The y-intercept of the quadratic. So if I was to do that little graph again, the red piece is going to hit at pi right there. We'll call that pi, that height. And now the only way for this quadratic to meet at that function is when the y-intercept of that is the same thing. Okay, so that makes sense. All right, so far. So in order for this to be continuous, at least for the first two pieces, pi has to equal b. All right, we're going to do a similar idea for the last two, right? Because again, we have two decision points. So the first one is when b is equal to pi, but now we got to deal with these two because the second decision point is at 1. So we got to make sure that the heights match up at 1 for the second two pieces, right? So let's set them equal. So we're going to say x squared plus ax, we know the b value has to be pi, Okay, that's the only way for the first two to be continuous, and we'll set that equal to the 6x plus 5. Okay, so that's when the y values are the same, and the decision point where I need this to happen is at 1, so we'll plug in 1 anywhere we see x. And then it's just algebra from here. Okay, so the calculus part is done. All right, so we need to ensure the same height, and we need to ensure the location of that height. All right, so what is this? Just 1 plus a plus pi equals, 11? And then subtract 1 from both sides. So we're going to subtract 1 and subtract pi. So a is going to be equal to 10 minus pi. Okay, that's just a regular number. Remember that pi is just irrational. Okay, so to answer the final question, we're going to say that h of x is continuous when b equals pi, and a equals 10 minus pi. Okay, that will ensure that at the decision points, they are all connecting. Okay, that's the essence of continuity. All right, okay, so similar idea for this one. This one you need to know a little bit about inverse trig functions to get this, but the calculus piece is the same, okay? So we have some kind of quadratic in the first piece, and then we have a trigonometric function, it's just sine, and the decision point is at 1. All right, so to ensure continuity, let's ensure that the y values will be the same. And we want to make sure that the y values are the same at 1, so we'll plug in 1. So we have 1 squared equals sine of b times 1. And then it just becomes 1 equals sine of b. Okay? Now, when you have this, when the variable is the argument for sine, we have to use the inverse sign. Okay? So you can either write it like this. You can say sine inverse, or you can say arc sine. Okay, we tend to use arc sine when you're using like a graphing calculator, but if you're just showing it on paper, sine inverse is fine. Okay, but they really mean the same thing. All right, so what happens when you do that is things are going to switch up. Okay, so when I'm taking the inverse of sine, so I'll do it over here. So we're going to say sine inverse, and because it's the inverse, we're going to switch. Okay, we're going to switch the argument and what it's equal to. So sine inverse of 1 is going to equal b. All right, there's just a little bit of trig and algebra mixed in. So essentially what this means is, where is sine, the sine function, equal to 1? Okay, that's essentially what I'm asking. Okay, and that's going to end up being the same as the value of b. All right, but the key here is to understand that this is asking you where is sine equal to 1. So we're going to call in the unit circle. All right, and I know that right up over here, the values would be 0, 1, and the y value is sine. Okay, so in radians, right at the top here, this is pi over 2. Okay, so now we know that sine of pi over 2 is going to be equal to 1. All right, so if we were to write this again, we know that, let me just kind of go over here. So pi over 2 is equal to sine inverse of 1. And then if we were to flip it back in, we know that sine, without the inverse, because now we're going back, we're just going to flip the argument and what it's equal to. Sine of pi over 2 is equal to 1. All right, and that's the value of b. All right, so we're going to say, what was that function? It was f. So we're going to say, as the final answer, f of x would be continuous when b equals pi over 2.